All right, hello. Today we're solving LeetCode 210, course schedule 2. So we're given num courses labeled from 0 to n minus 1, or num courses minus 1. And we're given an array prerequisites, where prerequisites I equals A, B, and indicating that you must take course B before you take course A. All right, so in this example here, an array of 0, 1. So this means that you must take course 1 before taking course 0. We want to return a valid ordering of all the courses. We want to return a valid ordering to finish all the courses. If there are many valid answers, return any one of them. And if it is impossible, return an empty array. All right, so here's an example here. And we can actually see that prerequisites can be modeled as a directed graph where each node is a course and each edge is a prerequisite. So in this example here, we can see that course 0 actually has no prerequisites because there's no directed edge towards it. So we can just take it. And that gives us the option to take course 1 or 2. And from 1 or 2, we can allow it to take course 3. And all we need to do is return a valid ordering. So as you can see, we can take course 0, then course 1, then course 3, then back to 2. Another valid ordering would be taking course 0, 1, 2, then 3. And there's even more. 0 to 2 to 3 to 1. So this is just to illustrate that there are many valid orderings to complete all of the courses in this example and many other examples as well. But let me show you a counter example. Let's say there's a directed edge from 1 to 0. So that would mean in order to take course 0, we'd have to take course 1. In order to take course 1, we have to take course 0. So as you can see, there's a cycle because that would be impossible to do. So we'd have to return an empty array. So essentially, if there's a cycle in our directed graph, then we return an empty array. If there is no cycle, then we return one of the many valid orderings. So let's quickly go to the code. All right, and if you watched my video on course schedule 1, you'll know how to detect cycles in a directed graph, and we'll just be using most of this logic for course schedule 2. And if you're not too sure about that, I'll make sure to link course schedule 1 down below. But just to quickly recap, we did a DFS with a 3-state cycle detection where 0 represents that a course has not been taken, 1 represents we're currently taking a course, and 2 represents that we've taken a course successfully. We have DFS with our base case, and if we find that a prerequisite is a course that we're already taking, we return false. So this line here, line 12, tells us that if we are in a cycle, we immediately return false. Then we just loop through all the courses. And if there is no cycle, we return true. So the simple modification is we need to return a valid ordering to take all the courses rather than just a Boolean if we can take the courses. As you can see in the example before, the ordering was represented in an array. So we can make a variable called order and set it to an empty array. Now, if we scroll down, we see that when we set state of a course to 2, which means it's been successfully taken, all we have to do is append that course to our order. So order.append course, right? So every time a course gets taken in our DFS, we just append it to our course array. And here, if we detect a cycle before we return false, but this time we want to return an empty array because that means we cannot take all of the courses. Instead of returning true if we can, we want to return the current order, right? So let's try it out and see what happens. And our solution has been accepted and it's relatively efficient. Actually, it's very efficient. If you have any questions, comment down below and make sure to watch course schedule 1 if you haven't. Peace. Drop a like.